So, hello everyone. Um, my name is Sebastian. I'm CTO of yWorks and I love connected data, diagrams, and visualization. I met Koji a few years ago in London at Neo4j's Graph Connect Europe, and the photo you see there was made the last time we met in New York City last September, again at Neo4j's Graph Connect conference. So thank you very much, Koji, for inviting me today. I'm very happy to be here, at least virtually, and I hope you will like my presentation. Um, Now, why am I here today? It's because I want to tell you about yWorks, the company I work for, and the products that we create. First, let's start with some facts. yWorks was founded in the year 2000 as a spin-off of the University of Tübingen here in Germany. And we have about 26 employees and roughly 20 of them of which are software developers that work on our products and provide support to our customers. We are specialists for graph drawing software solutions, and our software is trusted by hundreds of corporations all around the world, both in Japan, but also in Europe, in the US, and everywhere else. So what is it exactly that we create? Basically, it's all about graphs, diagrams, and networks. And most importantly, it's about the visualization of relational data of any kind. So we create a couple of products. The most important one is our software diagramming SDK family, which is called YFiles. More on this later. But we also create tools and applications around diagramming, visualization, and graph editing. This is there's a tool called YEd, which I'm going to show you soon, which you can use in your day-to-day office work as a diagram editor solution. There's also other tools that we provide, mostly for software developers, which is the Neo4j Explorer that we have, but it's also algorithms for other tools like Cytoscape, which is a biological tool analysis tool, and also tools for software documentation, visualization, and so on. So I'm starting by showing you the software called YEd, which is a generic diagram and graph editor, similar in functionality to tools like, for example, Microsoft Visio. It's meant to be used by end users and does not require any programming skills. People use it all around the world for creating diagrams manually and automatically. So here's a sample diagram. I can edit it and add new nodes to it. And I can import my data from XML and Excel sources or CSV files. And I can export the diagrams to SVG, PDF, PostScript, Windows EMF files, bitmaps, and much more. Also, poster printing is supported. And the true power is that it offers a full range of automatic layout algorithms. And so you can create your graph manually and then automatically have it create a new automatic arrangement for you. There's a whole lot of different settings, and you can use it to analyze your graph by laying it out or by actually running graph analysis algorithms, for example, centrality measures. So I can run between the centrality measures, calculate importances of nodes, and so on. YEd is available as a desktop application, but we also have it available for the web. YEd is available for Windows, macOS, and Linux, and the desktop, the web application doesn't have to be installed on the PC. It runs on all modern browsers and even on your tablets or smartphones if you want to. Also, if you are using Atlassian Confluence, the enterprise wiki, there's a plugin available that you can use to get the power of the tool into your Confluence installation so that you can edit and share diagrams in Confluence too. So what exactly is YFiles? Now to the technical background. All these programs that you've seen have been built on top of our programming libraries, YFiles. And you as a software developer can create similar or maybe more specific applications using the YFiles software development kits. So YFiles is for software developers. It's a software development kit, so it's not a complete application. You need to program, and you will have the pleasure to use the APIs and do some programming. The SDK is available for different platforms and programming languages. This includes both desktop and web, as I said, but more on that later. And you can use it to visualize connected or related data. That's all what it's all about. So you have nodes and edges. Some call it vertices and links or shapes and connectors. And the software will help you visualize and work with this data. Also, you can do graph analysis. So we provide efficient implementations of really complex algorithms for you to analyze your data and diagrams. You can use the results of these analysis runs to give feedback to the user or to drive the visualization or the automatic layout. Automatic layout is at the core of our library. So we provide the most complete set of automatic layout algorithms available commercially. These algorithms will help you generate great visualizations of your data automatically without having to manually arrange the items on the screen. So it's not about bar charts or pie charts. Is there a question? No. Or about function plots. So if you're a programmer, what options do you have? On the desktop, you can use Java to use Swing and JavaFX to create programs, or you can use program in C# to create Windows Forms or Windows Presentation Foundation applications. And for the web, we have the JavaScript version called YFiles for HTML. There are and there were even more products, but these are the most important ones right now. We're also working on Python and C++ versions, but these are not yet available. The samples I'm going to show you next have all been created using YFiles for HTML with JavaScript or TypeScript, but they could have been created using the other variants too. So what are the typical use cases where you could use these APIs? These are the ones. I can't read them to you, but I can translate them to you. So it's about all kinds of charts, modeling, all kinds of diagrams, mind maps, network structures, basically anything where connected or relational data is used. As you see, this as a whole range, and we are not specifically targeting a specific diagramming type, but our solution is a generic solution that allows you to visualize any kind of relational data. Here are some more visual examples. This is what many customers have used YFiles for in the past. Basically, there are two main categories. So one category is viewing and exploring or understanding existing data, optionally with some interaction and analysis. And the other category adds editing and creating diagrams and data manually or semi-automatically, so that you actually let the users create the data interactively. So you can create new applications, and the important thing is that every aspect of the application that you as a developer create can be customized to your very exact specific requirements. For example, you determine where to retrieve the data from. It could be from a graph database, from a REST service, a file, or it could be created in memory or manually. Any data source is possible. You can also determine how the elements look like, what information is displayed on the screen, and how you render that information. You can tell YFiles how to automatically create the layout and arrange the elements on the screen. And you can tell it what aspects of the data should be highlighted and maybe what constraints you have. So you can put nodes into a partition grid. You can tell the algorithm to place nodes into a certain compartment. You can constrain the direction where edges leave and enter nodes. You can determine the order and the nesting of elements, and so on. And of course, you can determine how the user can actually interact with the visualization. If and how they can modify the data, or how they can explore the diagram, and how maybe the diagram or the application interacts with third-party systems. So let's look a bit deeper into these options. And we'll start with layout. There's a huge set of different layout algorithms available. The main styles you can see here. So there's the hierarchical style, which highlights a certain flow in your data. There's the organic or force-directed style, which is great for networks. And there's an orthogonal style, which looks very technical but doesn't have any flow information. And there's various variants for tree-like nested data, the balloon layout and the regular tree layouts, as you may know them from other tools. And there's radial. But to truly understand the flexibility that we have, we need to see those in action. So let's try a live demo and see the automatic layout. Just a second. So these are the demos that come as part of the software development kit. And among these, there's a demo that shows how to configure the different layout styles. So this is an interactive demo. It uses YFiles for HTML and runs all in a web browser and on modern mobile devices and tablets. It does not require an active server component. All of the calculations are performed right inside the JavaScript engine of the browser in your own device. Now, you can actually find the code of the demo on GitHub and in the evaluation package so that you can get an idea of the coding, but I'll get to the coding later. As you can see, there are many different settings available for each algorithm. For example, for the hierarchic style, let's change some settings and see how that affects the layout. I'm doing this interactively now, but of course there's an API that you can use to do this programmatically. The algorithm can also take into account nested groups, so that you have elements and groups of elements nested and have them rendered in a custom layout. There are many different styles available, and let's just briefly go through all of them, or through some of them. So this is the organic one that I showed you before, and again there's a lot of different options that you have that will influence the layout, so you can create more compact or less compact results, and there's hundreds of different settings that you can use. The algorithms are flexible enough to actually take into account labels and edge thicknesses, so that if I run an algorithm, they will make sure that edges and labels are clearly visible and won't overlap with other elements. The next style I'm going to show is orthogonal, which, as I said, tries to create planar visualizations with very few bands, with very few banding points, and ideally no crossing edges. And then we have the circular layout, which is great for showing connected components and interdependencies between different groups of people or networks. But we can also configure it to create different visualization, for example, using edge bundling on a single cycle over here. Then there's the classic tree layout algorithms, which have a lot of different options available. So even if you have really large trees, you can try to create a more compact result like this. Oops, that's the wrong one. Wrong spacing. Sorry, didn't work. I'm going to go to the next one. There's tree layout. There's the balloon layout, which is also a specific tree layout, and it also has lots and lots of options which will generate different visualizations depending on the structure you want to highlight. And the radial layout is very similar to the tree layout, but it's actually closer to the hierarchic and can also easily deal with non-tree edges. So if there's not a clear hierarchy in your graph, the layout will also be able to calculate rendering for these. The next layout is serious parallel, which is great for graphs which have an inherent flow and parallelism. So like in computer programs where there's forks and joins and parallel or sequential execution. But we also have layouts that only calculate edge routings. So given a fixed set of locations for the nodes, we can calculate a perfect edge routing for these node positions. And again, you can, for example, tell it to create fewer bands, to create shorter edges, or to create less crossings, and so on. So there's hundreds of options there you can play with. There's a lot more to this. I invite you to just play with the layouts later in the online demo. It's free for everyone to play with on yworks.com/demos. So it's something you can try out yourself. And of course, if you evaluate the library and do the programming, you can play with this too. Okay, so what's actually very important, other than the layout, most of the time for developers is being able to configure the look of the elements in the diagram according to their very specific requirements. So the nodes that we have seen looked very boring, just orange rectangles. But of course, you can create more sophisticated visualizations. This demo is a great example for this. It's using Vue.js, which is a JavaScript framework, but that is not a requirement. YFiles for HTML integrates well with third-party libraries like React or Angular or Vue.js or even D3. And those tools can help you with the implementation of your custom style visualization. In this example, you can see that data is bound via templates to visualizations. And we can use advanced techniques like CSS3 transitions and animations to create a great and unique user experience. So let's try it. So if I zoom in into the diagram, more information becomes available, and that information actually correlates to the data that I have over here. When I apply the change, I will see that data changes. I can change the visualization and create custom visualizations that specifically suit my use case. So, but it's not just about the look of your diagrams. What really matters in more complex situations is actually user interaction, how the users can work with the interface that you provide to them. Good interaction helps end users understand their data and work with it efficiently. So let's go back to this one. I'm going to give you just a few different examples that show what kind of interaction and exploration possibilities you get with the programming library YFiles. There's a lot more to that you can do. And again, I would like to invite you to play with the online demos or download the library later on to really start coding and have the fun. So one great example of custom interaction is the organization chart demo that we have. It combines custom visualization with drill down techniques, exploration and filtering, as well as a unique user interaction. So I can click on elements, see the details. Let me just increase the size. I can click on elements, see the details over here. I can expand the graph and drill down to find out more, or make the graph smaller to get a nicer overview. And of course, I can expand all of them to get the big picture back. I can do searching, like Eric, and so on. So this is all. The YFiles component is just inside this rectangle. Everything else is just part of the demo or would be part of your very own specific application. You could make it to suit your very specific exact requirements, and it doesn't have to look like this. This is just an example. Another example for interaction is in the network monitoring demo. So this demo shows not a real one, but a simulated computer network and network of computers and routers and switches. And you can see packages flowing from one point to the next one, and you can actually click on elements to find more information to get live data from the network. For example, I can see the network load for the different elements. And by the way, this is using D3.js for creating the charts over here. The rest is YFiles, but the charts over here is using D3. So we are open to using third-party software solutions within the programs that you can create with our software libraries. But this is actually not just showing live data, but I can actually interact with the system. I can send events to outside third-party services to, in this case, disable switches and see how the network reacts when I turn off the switches. This is just a simulation, so don't worry. The internet is still working, but just to show you what possibilities and what kind of interactions there are possible. And the last one is a decision tree demo, which shows some unique interaction. So this is kind of like a sorry, like a questionnaire, like a flowchart, an interactive flowchart, where you can where you get questions and answers, and you can choose answers, and then you can interactively find out which car to buy in this example. But if you want to do a more sporty, you can get different results. So this is, again, this is a custom visualization and custom interaction. And this is something that you can create with the help of the diagramming library. So, and the last one is if you have larger networks to explore, you will love to see this neighborhood view feature we have in this demo. So imagine this is a part of a larger network, and if you navigate through the network, you can have a utility view over here, for example, that will show you the direct dependencies of the selected elements. So rather than having to look at all these connections over here, you can have this neighborhood view over here show you how the elements are connected with each other. And this view is generated dynamically, and I can use it to interact and navigate the system. So there's different variants, so I can show the neighborhood or just the successors up to a certain level, and so just one level deep, and I can show the successors and so on. Basically, any logic can be used to determine what elements should be displayed in the additional view over here. Yeah, so this concludes the interactions which I wanted to show you. Now that you've seen what visualization options and interaction possibilities there are, let's see some code how to actually connect your Neo4j databases with YFiles. So let's get back over here. We've actually written a blog post that shows how you can get started with YFiles and Neo4j in a very short time. With less than 100 lines of code, we can create our own custom white labeled web application that can connect to our Neo4j database, then query some data, and finally render that data onto the screen. For this, we use the Neo4j bold JavaScript driver, but you could use any other middleware technology to actually get the data into the program. So now finally some code. Here's the code. As you can see, it's really short. There's a lot of comments, and it's just, well, 100 lines of code, basically. Let's go through that quickly. So this is JavaScript. It's using ECMAScript 6 features, classes, and modern JavaScript features. So we're using imports to actually import the YFiles library, the view component. And as I said, we're using the Neo4j driver, the bold driver, to actually query the data. So this is basically how the application works. We create Neo4j, the bold driver, for which we, in this case, hard code the IP address of our Neo4j server, and we also hard code the authentication credentials. Then on the HTML page, we create the graph component. Now this is the part where the YFiles library comes in. We have a div element defined on the HTML page, which is very simple. Let's just look at this. So that's the HTML page. And there's this div element. And we create the graph component over here and tell it to place it into the graph component div element on the HTML page. Then we make the element interactive and tell it so that we want to view the data only. We don't want to create the data. There's more to this later. I'm going to get back to this quickly. But basically what next happens is that we actually load the graph from the Neo4j database. YFiles is not does not require a Neo4j database, and there's actually not even a ready-made connector. But as you will see, the code that is required to connect to any data source is very easy to write. And it's basically just these lines over here. So what we are doing is we are running a custom Cypher query. There's a helper function, run Cypher query, which just uses the Neo4j driver to read a query from the driver and return the result. And the results that we get back is just a JavaScript object. It's provided by the Bolt protocol, and it contains all the node elements. And if we run a second query, we can also query the edges between the nodes that we fetched in the first query, like this. So now we have two JavaScript objects with the nodes and the edges, which are just ordinary JavaScript objects, and they could be coming from anywhere else. And we use this YFiles helper class to actually build the graph from the JavaScript data. This is a generic tool that can help us iterate the results and map them to a graph visualization. We specify how we want the node to look like. We specify a style so that they're going to be ellipses in this case with a light blue fill. We tell the builder how large our nodes should be. In this case, 100 pixels wide and 30 pixels high. And we tell it where to place the labels on edges. So if there are labels, they should be rotated along with the edge, on the side of the edge, with a certain distance. And now we pass it actually the results from the Neo4j Cypher query. We pass it in as the sources for the nodes that we are going to create. We need to tell it how to identify the nodes, because the edges have references to the nodes, and these are the Neo4j start and end properties. So we we tell the engine that it has to look for the start and end property in the Cypher query results to determine the source and the target nodes for each edge. And we also, in this case, we query the type of the Neo4j relationship and put that as an edge label onto the edge. Now in the example that I have, I was using the movie database example from Neo4j. So I specifically for the nodes which are labeled movie in the Neo4j database, I'm changing the style over here. So I want to have a round rectangle with a yellow fill for the movies. And actually, I'm also adding some labels to the visualization over here. And I'm not going into the details right now here. but you can find it in the annotated blog post if you want to. The same thing I'm doing for the specific relationship called acted in the movie database sample, and I'm going to assign it a blue stroke and with a blue target arrow at the end of the stroke. And basically that's it already. After I instructed the builder how to create the graph, I tell it to actually run the queries and build the graph structure. And finally, I'm calculating some layout so that I get a nicer result and not a nicer initial result for the arrangement of the elements on the screen. So now let's get back to the running to the browser. It's over here. Let's just reload this. So this is the app. Once it loads, it queries the database and creates this graph visualization for me. So this is the first 25 nodes of the Neo4j database, along with their relationships and the description of the relationships and a radial layout. The other part over on top over here was I added some code to actually show tooltips for the user, so that when I hover over a node, I'm going to get a tooltip that shows all the properties that are part of the Neo4j query. So if I hover over this node, I get the title, the tagline, and the release date. And for the users, I get their name and when they were born. And the second part, the second customization that I did was that when a user double clicks on an item, and the item is actually a node, then we are doing another layout run that puts the item that the user has clicked on into the center of the visualization. So this is what it looks like. I can double click on an element and then it will put the element into the center of the visualization. So if you're interested in this one, by clicking, I can create new layouts, always centered around the element that I clicked on. And that's basically it. That's all the code that I required to create this not very nice looking, but custom visualization. You can combine the techniques with the template styling and the animation to create nicer visualizations of the nodes, of course. And you can use all the features that you've seen in the other demos and that are available in the package to use them together with your Neo4j database. And so let's get back. So what we also did is we created a tool for those of you who don't want to program that does pretty much exactly what I just showed you. It uses Bolt to query the database and allows you to interactively explore your Neo4j database. So that's the Neo4j Explorer, and it's available on our website for everyone for free to try. There's no registration required. And that's it. So it's on yworks.com Neo4j Explorer. And you can just connect it to a database, and then it will go and fetch the schema of your Neo4j database. So it will tell you that there are in the movie sample database there are persons and there are movies, and the movies have properties, when they were released, the tagline, and so on. And there's also relationships, between persons and movies. So there's, in this case, there's the relationship directed, produced, reviewed, and wrote. And so you can get a better understanding of how your data is structured in your database. Of course, for most databases, the schema will be more complicated than in the simple movie database sample. But you can use this to better understand the relationships between your to better understand the structure of your data, but you can also go ahead and actually browse your concrete data in the database. So I can, let's search for some movies like Matrix, and let's show them all in the diagram. And I can load more elements, just like you may know it from the Neo4j desktop application. But you can get more sophisticated layouts, and you can run graph analysis algorithms, for example, centrality algorithms, to better understand which which elements are important in your graph. But this is just an example of what you can do. There's many more options that you have, so I invite you to play with that application too. As I said, it's available for free on our website, and it doesn't send the data to our service, so it directly connects your browser to your database. So the data is only shared between your computer and your database, but doesn't go out into the internet. So that's a cool feature for you to try out. Okay, so this was the demo about connecting YFiles with Neo4j. As I said, the sources is also available on GitHub. So if you go to GitHub for yWorks, you will find the sources that I just showed to you. But these are also linked from the blog post that you will find on our website. That's basically it for my presentation. I'm open to any questions you might have. I hope that you have seen what you can do with YFiles and the products that we have, how you can create your own applications for your end users or your customers, and how you can connect data, import data into your own applications, create custom visualizations, custom interactions, and great applications. That's all for me for now for this presentation. Happy diagramming to you. If you have any questions, feel free to ask them now, or send an email to me or to Koji, and he will forward that email to me, and with any questions you may have. Thank you.
Thank you, Sebastian. Someone has a question? No questions? Yeah.
Thank you. YFiles, it seems to be completed, but I want to ask you, can you hear me?
Yeah, I can hear you very well, thank you.
Okay. Do you have any big feature that you plan to release in the future?
In the future, new features?
Yes. Big feature.
Yeah, big features. So what we are always adding new features. The library is quite mature, so there's already a lot of features available, but we're always adding new automatic layout features that allow you to, for example, to create more compact layouts, to work with bigger graphs, more data, because everyone has big data and lots of graphs and lots of nodes. So we always work on improving the performance and on adding more features. For example, in the next version, we have more examples of how to use in the next version of the JavaScript version. We have more examples that show how to use WebGL for creating beautiful visualizations in your diagrams, because we support SVG, as you have seen, as well as Canvas, but also WebGL, and all at the same time. And with all these technologies used together, you can create beautiful visualizations. And the next release, which is going to be released actually next month already, will focus on creating more beautiful visualizations easier. So you can use more CSS tricks and animations to easily animate your graphs and diagrams, as well as WebGL. And we also focused on keeping up to date with the JavaScript technologies. So in the next release, you can use NPM modules to more easily create your applications from scratch, so that you can use it with Angular, React, Vue.js, and all the hip tool chains with Webpack and so on, so that you get code completions out of the box. And so it's all about productivity, developer productivity, and enabling developers to create more beautiful visualizations.
Oh, thank you. Question, more question.
Mhm.
Can connect to AWS Neptune?
Good question. The answer is very easy. Yes, it can. um, uh, as long as you can get the data into the browser, it doesn't matter where the data comes from. So it could be from a CSV file, from an ASP.NET server, an AWS server, or any custom technology. You could use WebSockets to query the data. As long as a programmer you can get that data into your program, you can visualize it with YFiles. So we have customers which run their applications on huge cloud installations like AWS, but there are also customers which run their applications on embedded devices like routers. So there are some sophisticated network routers that have YFiles built into the router firmware. So, and they connect to the live data of the router. So you can do both, go to connect to very simple small systems, or go into the cloud. It's all a JavaScript library. It does not require a server component. It's basically the duty of the developer to connect the data with the visualization. But as you have seen in the Neo4j example, that's actually very little code that is required to connect to data, as long as you have some way to connect to the data. So you may have to create a middleware server, middle tier server, to connect to the database that's inside AWS, but that depends on the way you architect your application. You can directly connect to the database, or use some middle tier proxy or whatever. But yes, the answer is, if you can get the data into the browser, you can have it visualized. So no matter where it comes from.
Oh, thank you. Answer.
Cool. Any more questions?
Sebastian, thank you for your explanation. I have a question. I'd like to show the Neo4j data on the map. How should I do? Do you have any idea?
You mean on a map like Google Maps, or like this?
Google Maps are like geometry, like a
Yeah. That's a good question. Yeah, we of course we can also display data on the map. Yeah, and this one is using it's not using Google Maps, but it's using um, Leaflet. I think Leaflet is called. It's an API to query to query the map data, but we use YFiles to overlay the actual graph data on top of it. So to answer your questions, if you have the geo data, you can actually put these on a map too, but you don't need to use the geodata. You can also use a generic graph layout and switch between the geodata and the actual structural data. This is actually not using Neo4j, but it can also be in Neo4j. There was an example with the new Neo4j geospatial API, where we created a sample application where you can calculate the routings of a map in Neo4j, of map data stored in Neo4j to calculate the shortest path between I think it was streets in Manhattan, New York. So yes, this is possible, and you can use third-party components like in this case Leaflet.js or the Google Maps API to get the pictures.
Thank you.
Thank you, Sebastian.
You're welcome.
This is the end of your session. Thank you.
Thank you very much. Thank you for having me, and have a good day. Perfect. You'll be coming to Berlin? We'll see you.
Yeah, of course.
Have fun and have a great day, you too. Yeah. Bye bye.